Hi everyone, this video is on finding the critical point or the turning point in a graph. Okay, so for example, if I have the graph over here, then the turning point will be at the point at which the curve changes its direction. Okay, so if we start from here, then when we get to the top of the hill here, we see that at that point the curve starts to descend, and then it gets to the valley over here. Then once it gets to the valley, it starts to change the direction again. It goes to the top of the hill, changes direction, and then starts to come down here. Okay, so the point at which the curve changes its direction is known as the turning point or the critical point of the curve. That is if we have drawn the curve. Then if we have given an equation or a function that represents the curve, then there is another way that we can determine all these turning points or all these critical points. Okay, so if we have a curve that turning point, it's up on a hill like this, then at that point we call it a local or relative maximum. And then when the turning point is downhill like this, like a valley, then we call that a relative or a local minimum. And if it's neither a down or a valley, or neither is it the top of a hill, then it's called a saddle point. Okay, so there's several ways of finding whether a critical point or a turning point is a relative maximum or it's a relative minimum or it's a saddle point. Okay, so we're going to use calculus to do that instead of always graphing our curve. All right, now we notice that at the point on top of the hill here, okay, there is no change in the x direction and there's no change in the y direction. Okay, so at this single point here, there's no change in the y and there's no change in x. Okay, so at that point the slope is equal to 0. Yes, oh sorry, the gradient is equal to 0 because gradient or slope is changing the y direction over change in x. Okay, so if there is no change in y and there's no change in x, then the gradient at that point is equal to 0. Likewise, the gradient at this point also equal to 0 because there's no change in y and there's no change in x. And then at the saddle point here too, there's no change in y and there's no change in x. So the first derivative at all these turning points are equal to 0. Then another thing that we have to also consider is if we want to determine whether a critical point or a turning point is a local or a relative maximum, then the second derivative evaluated at that point or at that critical point must be less than 0. Okay, so if we find a second derivative at this critical point, then that value must be a negative number. Okay, and then if we find a second derivative at this critical point, that is at the local minimum side, then that second derivative must be a positive number. And if the second derivative of the curve evaluated at this critical point is equal to 0, then that point is a saddle point or it's a point of inflection. All right, so with that being said, let's look at examples and see if we can determine the critical point and then the nature of these critical point. That is whether it's a relative maximum or a relative minimum or it's a point of inflection. Okay, and then if we get a critical point, we also want to know the point at which these turning points happen. Okay, so let's take a look at the first example. We have that y is given as, okay, so we have been given the equation of the line as y is equal to 3x squared plus 3x plus 1, and we want to find a critical point. The critical point is the point at which the gradient is equal to 0. So we find a gradient of this curve. Okay, so we find the gradient of this curve, and the gradient is simply the change in y over change in x. Okay, so this is equal to minus 6x plus 3. Now remember, at a critical point, the gradient or the first derivative is always equal to 0. Okay, so we have minus 6x plus 3 equal to 0. This means that our x is equal to 1 over 2. Okay, so it means there is only one turning point or one critical point in our curve. Okay, so we want to know if x is equal to a half, then what will be the y coordinate? Okay, so because a point consists of two coordinates, that is the x coordinate as well as the y coordinate. So if x is equal to 1 over 2, then what is y? We substitute this value into the expression, which is already given. That is minus 3x squared. So wherever we see x, we're going to put a half there, plus 3 into bracket a half plus 1. Okay, so this is equal to minus 3 over 4 plus 3 over 2 plus 1. Okay, so this is equal to minus 3 over 4. This whole area is going to give us 5 over 2. Okay, so plus 5 over 2. And this is equal to minus 6 plus 20 all over 4. Sorry, it's not going to be all over 4. It's going to be all over 8. Okay, this is equal to 14 over 8, and that is 7 over 4. Okay, so the critical point is at 1 over 2 and 7 over 4. Now we want to know the nature of this critical point, whether it's a relative maximum or it's a relative minimum or it's a saddle point. Now once again, if the second derivative is a positive number, then it's a relative minimum. If it's a negative number, then it's a relative maximum, and if it's equal to 0, then we have a point of inflection. Okay, so, or saddle point. So we have our first derivative as minus 6x plus 3. We're gonna find the second derivative, which is the squared y over dx squared, and that is going to give us minus 6. Minus 6 is less than 0, or it's a negative number. Okay, so since the second derivative is a negative number, it means the critical point, which is 1 over 2 and 7 over 4, is a relative maximum. Alright, so let's look at what we found. We were given a curve, and we want to know the point in our curve where the curve changes direction. So of course it's going to be a wavy curve. So if we want to know where all the points at which the curve changes direction, which is the critical point or the turning point, then we know that at the turning point the first derivative is equal to 0, because there's no change in y and there's no change in x. Okay, so if we find the first derivative, then we equate it to 0. Okay, that will give us the point at which the curve changes its direction. So we first of all got our x to be equal to a half, and to know what the other y coordinate is, we substitute that into the function that was given, and we have y to be 7 over 4. So if this is the critical point, then we want to know the nature of that critical point, whether it's a local maximum, or it's a local minimum, or it's a saddle point. Okay, and that will be determined using the second derivative of the function, and differentiating our function twice, we get minus 6. Minus 6 is a negative number, and so the critical point is a relative maximum. Okay, if you have any questions, please feel free to leave them in the comment section. If not, try your hands on the following exercises.